So here we're talking about integrals that involve e to the x. And we've already kind of just real quickly discussed that if we have the integral of e to the x, we know that that's e to the x. Because the derivative of e to the x is e to the x, the antiderivative of e to the x should also be e to the x. So on the first problem here, we just have a constant times it, so we know that we can say, well, that is the same as the constant times e to the x and then plus c. The problem becomes whenever our power is something other than x, because with the chain rule and the derivative, we know that the derivative of e to the x is 2e to the 2x. So the antiderivative is sort of opposite of that, and we're just going to let u be 2x. So we do u substitution again. This time our u is going to be the power. And this is what's a little bit confusing when we look at all the different types of u substitution, is getting in our mind what u can be. When we're involving e's and powers, it's going to be the power. So du is going to be 2. We need that 2 in there, taking a half out. So the process is still the same even when we have different types of functions. So the antiderivative of e to the u is just e to the u, and we put that 1/2 with it. And then we go back and put in what our u was, and then there we have our answer. Okay, on the next problem, u is normally the power when we have e to the x, so u is going to be 3x minus 7, which means du is 3. We need to put that 3 in, take a 1/3 out. So we're going to have 1/3 integral e to the u. We know that that is 1/3 e to the u. Plug in what we know for u. And there's our answer. Alright, so another similar type of problem, we're going to let u be the power. So du would be the 2x. Notice we have an x but not the 2, so put the 2 in, take the 1/2 out. So 1/2 integral e to the u. Because all of that's du. And then so we just have e to the u. Well, again, we know that that's e to the u with a 1/2. Plug back in what u is. And then that's our answer. The next two are common problems where students make mistakes, and so I wanted you to see this. I will tell you that you're still kind of thinking of the same process, that let's let u be the power. When you have an e there, a lot of times that is true. So let's see what happens when we let u be the power, which is square root of x. Remember that this is x to the 1/2. So the derivative here would be 1/2 x subtract 1 to the negative 1/2. Well, that's all fine and dandy, but how does that work here? Alright, so this would be e in the u. Okay, x to the negative 1/2 is the same as the square root of x being on the bottom. So this is what's there without the 1/2, so we need a 1/2, meaning our 2 comes out. So really the problem is very nice if you can figure out that u and du part. So that we have 2 integral e to the u, which is just 2e to the u. Substitute back in our u, x to the 1/2, or you can put it as the square root of x, and then there's our answer. Similarly, number 6 is very much the same. We're still going to let u be the power. Notice that's x to the negative 1, and now we want to find the derivative. Not the antiderivative, the derivative. So we want to use the power rule where it's negative x to the negative 2. Again, that's all fine and dandy, but how does that help us? If you think about it, our x squared is on the bottom, so that's already there. We just need that negative. So this is the same as negative integral e to the u, which is negative e to the u And then we substitute back in what u was, which is 1 over x, or negative x to the negative 1, whichever way makes more sense to you. And then there's our answer. Okay, we got just a couple more problems to look at. And this is one, both of these are ones to show you, you don't always let it be the power. Sometimes it's what's on the bottom, or sometimes it's something in parentheses. There's lots of different things when we think about what u can be. And so I wanted you to see these two examples. In the first one, u is going to be what's on the bottom. And I'll show you why that makes sense once we find du. Du is e to the x, and that's what's in there. So this is what u is, this is our du, and we can just bring that to the side. So we've got 1 over u, and then our du is just to the side. If you put the du on top, that's okay, but a lot of times that confuses students, so I like to put it out by the side. The antiderivative of 1 over u is natural log of u. And then we can plug back in what u was, and then leave it like that. So we're sort of combining our u substitution, how u can be a power, u can be the bottom, or u can be something raised to a power. And it'll just come with practice about telling which kind it's going to be. So this last example here, again, u is going to be what's inside of here, and I'll show you why. And it's because du is the derivative of that, which is just e to the x, and that's what's in the problem, so that's really nice. Nothing to change. You do just say the integral of u du. The antiderivative of u is u squared over 2. And then we want to substitute back in what u is, which is e to the x minus 3 squared. And then that's our answer.